Everybody, and welcome to the last talk of this week's sessions. We're going to end our session today with a talk of Dr. John Cook, who will present a talk called Using Inoculation and Critical Thinking to Counter Climate Science Denial. I am going to introduce Dr. John Cook to you. John Cook is a research fellow at the Climate Change Communication Research Hub at Monash University. He is also affiliated as an adjunct faculty member to the Center for Climate Change Communication at George Mason University. In 2007, he founded Skeptical Science, a website which won the 2011 Australian Museum Eureka Prize for the advancement of climate change knowledge and 2016 Friend of the Planet Award from the National Center for Science Education. John authored the book Cranky Uncle versus Climate Change that combines climate science, critical thinking, and cartoons to explain and counter climate misinformation. So Dr. John Cook will take your questions. We'll pause during his talk in case there's questions. So as I said, don't be shy, don't wait until last minute because otherwise time will run off. Whenever you think of a question, put it in the chat. And when he pauses, I'll make sure to read your questions to Dr. Cook. So welcome, Dr. Cook, go ahead.
Thanks very much, Fernanda. So I'm sharing my slides. Hopefully you're all seeing them okay at the moment.
Yeah, they seem fine.
Great. Okay. So firstly, well, thanks very much for the invitation to speak and the opportunity. And I'm following on from Stefan Ludowski, who was my PhD supervisor, and Sander van der Linden, whose research mirrors a lot of mine. And I wasn't able to see their presentations because it was the middle of the night for me and I was asleep. But apologies if there is any overlaps between our work, because a lot of it does parallel each other. And I actually wanted to begin by talking a little bit about some research that was published by Sander van der Linden. In order to effectively counter misinformation, it's important to understand how misinformation does damage. And I know that Stefan Ludowski talked about the different ways that misinformation does damage earlier today, but I want to talk about one particular aspect because that opens up, I guess, an insight into how to counter misinformation. And so the first part of my presentation was just look at this one study. And again, just to repeat Fernanda's introduction, if you have any questions, please post them in the chat and I'll be pausing periodically to answer questions. So in one study published in, I think, 2017, Sander van der Linden tested in an experiment what happens when people are exposed to different conflicting pieces of information, facts and misinformation. One of the messages that he showed participants in his experiment was the 97% scientific consensus that humans are causing global warming. The other message that he showed participants in his experiment was some misinformation that cast doubt on the scientific consensus. Specifically, he took an excerpt from a website called the Global Warming Petition Project, which featured a list of over 30,000 science graduates who had signed a petition stating that humans weren't causing global warming or humans weren't disrupting climate. And this is the results from his experiment. The first group, or the first bar in this bar chart, were people who were only showing the 97% consensus. And he found that it had a strong, significant positive effect. It raised people's awareness of the scientific consensus, and it also had flow-on effects, increasing their acceptance that climate change was real and human caused, and also increasing their support for climate action. The second group in his experiment, or the second bar in this bar chart, were shown only the misinformation. And for this group, there was a significant negative effect. It reduced their perception of consensus, it reduced their acceptance that climate change was real and human caused, and it even reduced their support for climate action. So this tells us that misinformation does work. It can have a negative effect on people's attitudes and perceptions. But the third group is particularly interesting because this is the group who were shown both the fact and the myth. And when people were shown both the 97% consensus and the misinformation casting doubt on the consensus, the two cancelled each other out, and there was no significant effect either way. What this tells us is that myths, misinformation can cancel out accurate information or facts. And this has a big consequence for science communicators, scientists, educators, because it means that even if we put all the effort in the world to make sure that our science is clearly communicated and engaging and gets out to lots of people, those facts can still be cancelled out by misinformation. So what's happening with this third group? Basically, the issue here is that when people are presented with conflicting pieces of information, it's a bit like those old episodes of Star Trek when Captain Kirk gets cloned and you have the real Kirk and the fake Kirk, and Mr. Spock has to try to work out which is the real one and which is the fake one. That's the same dilemma that the public find themselves in when they're presented with facts and myths. And the danger is if they don't have the ability to resolve that conflict between the two, to be able to tell which is which, then the danger is that they disengage and just believe neither. And so this is one of the most insidious ways that misinformation can do damage. It doesn't have to necessarily be convincing or based on evidence or coherent. Just by existing, it can cancel out facts and accurate information. But this also points to the solution to misinformation. If the problem is that people can't resolve the conflict between facts and myths, then the solution is giving people the tools to be able to resolve the conflict between facts and myths. Give them whatever tools they need to be able to take any information and be able to identify whether it's misinformation that has the danger of misleading them. And a very useful framework for doing this is inoculation theory. This is a branch of psychological research that goes back to the mid-20th century. And psychology researchers have found that taking the idea of vaccination and applying it to knowledge is just as effective as vaccination can be. When you get vaccinated, you're exposed to a weakened form of a virus, and that builds up your immunity so that when you encounter the actual virus, you don't get infected. In the same way, psychology researchers have found that when you expose people to a weakened form of misinformation, that builds up your cognitive immunity, your mental immunity. There's one book has that, the title Mental Immunity was published recently. And then when you encounter the actual misinformation out in the real world, you're less likely to be misled. And so here is an example of, or an excerpt of the inoculating message that van der Linden used in his study. He found that when you explained how the misinformation in the global warming petition project misled, and for example, the petition project is online, which meant that there was very little quality control and many of the signatures in the petition were fake. He also pointed out that the petition featured anyone with a science degree in the US, but there are millions of people with science degrees in the US. And so while 31,000 seems like a large number, it's actually a very small fraction of the total number of science graduates. And thirdly, he pointed out that because it was 31,000 people with a science degree, they could be having a degree in any field of science. So you had computer scientists, medical scientists, veterinary scientists, mechanical engineers, but less than 1% of the 31,000 signatories had any relevant expertise in climate science. And when he explained three of these ways that the misinformation misled. And this is the fourth group in his experiment. This group were first shown the inoculating message, then they were shown the fact and the myth. With this group, the inoculating message mostly neutralized the misinformation, and so that the facts were able to have a positive effect again. I might pause there for a moment and just check if there are any questions from anyone yet.
No, I don't think there's any questions yet, so we can.
Okay, so as you think of them, please post them in the chat. Okay, so what this research tells us is that inoculating people against misinformation is a proactive, preemptive way of building resilience against misinformation and basically neutralizing the misinformation before it has a chance to take hold. Now, at the same time that Van der Linden and his colleagues who are based at George Mason University and Yale University in the US, while they were doing this research, I was doing my PhD at the University of Queensland. I was based at the University of Queensland. My PhD was with the University of Western Australia. Just want to make sure I get that accurate. And I was conducting research into inoculation, which was eerily similar to Van der Linden, while the two of us had no idea what the other was doing. I was actually working with the same misinformation, which it turns out is one of the most potent and damaging forms of climate misinformation that's out there. And in my experiment, I also was showing people this misinformation in an experiment and measuring what happens. And these were my results. I found that when people were shown misinformation, it also had a strong, significant negative effect. But in this graph, the horizontal axis is political ideology. And so I found that climate misinformation doesn't work the same on everyone. It has a stronger effect on people who are more politically conservative and has almost no effect on people who are politically liberal, at least in this case. And so what this tells us is that misinformation is also polarizing, at least misinformation about climate change. And that means that when misinformation about climate change is being spread through the public, it's pulling the public apart because people are responding to it differently. Views about climate change are getting further and further apart, and it exacerbates and increases polarization. In my experiment, I also tested inoculating participants against misinformation, but there was a very significant conceptual difference between my inoculation and Van der Linden's study. In mine, I didn't mention the Global Warming Petition Project at all. Instead, the emphasis was on explaining the technique of fake experts, otherwise known as argument from false authority, and explaining what the fake expert strategy is, using people who convey the impression of expertise, but they don't have any actual relevant expertise. And also using a different example of this technique in a different topic area. In this case, the tobacco industry used the fake expert strategy in the mid-20th century to cast doubt on the scientific consensus that smoking causes cancer. What I found was when people were shown this general inoculation without even mentioning the Global Warming Petition Project, and then I showed them the Global Warming Petition Project misinformation, it was neutralized across the political spectrum. There's a slight slope to this line, but statistically it's equivalent to 0, which means that it's like a horizontal line across this graph. Basically, the misinformation had no influence on people across the political spectrum. And what this means is whether people are conservative or liberal, nobody likes being misled. And when you explain the techniques of misinformation to them, it can neutralize that misinformation, even when it's a group who are quite vulnerable or influenced by that misinformation. The other thing this research shows is that inoculations can convey immunity across scientific topics. When I inoculated people against tobacco misinformation, it also gave them immunity against the same techniques in climate misinformation. And I'll come back to this shortly. So explaining the rhetorical techniques and the logical fallacies found in misinformation is therefore quite a powerful technique or strategy in countering misinformation and neutralizing it. And I found a very useful framework for explaining misinformation techniques is the FLICC acronym, FLICC, fake experts, logical fallacies, impossible expectations, cherry picking, and conspiracy theories. And these are actually broad categories of types of rhetorical techniques. Over the last decade, I've been building up a taxonomy of different techniques that I've been documenting in misinformation, mostly about climate change, but seeing it in lots of other areas as well. And it's a lot. There's a lot of different fallacies and rhetorical techniques in there. And communicating all that, educating people to the point where they internalize all this and become effectively immunized against misinformation is a communication and education challenge. And I will come back to that challenge later and discuss one practical intervention I've been developing to try to overcome it. But again, I think I'll pause again to see whether there are any questions before moving on. And I think we are, whoops, no, actually, let me just pause there. Any more questions or any questions at all?
There's none in the chat, and I don't see anybody that has raised their hands either. So I think you can go on.
Okay, so after I'd completed this or published this research into inoculation, my next question was, how do you put that into practice? How do you build inoculating messages given a piece of misinformation? The first step in doing that is identifying what are the logical fallacies or the rhetorical techniques in a misinformation. Like, how do you identify those in a systematic, reliable way? And to answer that question, I worked with two critical thinking philosophers at the University of Queensland, Peter Ellerton and David Kincaid. And we wrote a paper where we developed a step-by-step methodology for deconstructing misinformation and then analysing it in order to identify the reasoning fallacy. Now, this flowchart is a lot to take in, but basically the key elements to it come down to 3 steps. If you're given a piece of misinformation, or you don't even know if it's misinformation, it's just a claim, a statement, and you want to see if there are any reasoning fallacies in it. Is it misleading? Is it logically invalid? Here are the 3 steps that we recommend that we outline in our paper. The first step is deconstruct the statement into an argument structure. Every argument has the structure of a set of starting assumptions or premises and the conclusion. And so you want to take a statement, and this is not a trivial thing. It's often statements are quite informally stated. People are just throwing words out there, but you have to try to extract meaning from it, and try to identify what are the assumptions that they're making and what is the conclusion. Once you have that argument structure, then you can go to the next step, which is check whether that argument is logically valid. If all the premises were true, let's assume that all the premises were true, does it necessarily follow that the conclusion is true as well? And if it is invalid, if it doesn't follow, that the conclusion would be true if the premises were true. Then what you want to do is identify what are the hidden assumptions, the unstated premises that would make this logically valid. And this is a bit abstract. I'll give you a concrete example in a moment. But this is often the most important part of deconstructing misinformation, because often statements, misinformation statements, contain hidden assumptions or unstated assumptions. And those unstated assumptions are often where the misinformation misleads. That's where the fallacy lurks. And so once you've got your argument structure in a way that's logically valid, the third and final step is checking all the individual premises. Are all the premises true? By breaking the original misinformation up into this structure, it allows you to pinpoint surgically where exactly misinformation goes wrong and what the fallacy is. So let me give you an example in a moment. But first, I'll just say that in our study, we then took the most common claims about misinformation, the most common climate myths, and we applied this step-by-step methodology to them. And so the end product coming out of that laborious process was identifying the reasoning fallacies in the most common myths about climate change. And once you have those fallacies and techniques identified, then you can build inoculating messages. So let me give you an example. And we'll use the petition project, which was that misinformation used in both van der Linden's experiment and my experiment that I described earlier. So step one is deconstructing this statement into a structure with premises and a conclusion. And basically the structure of this misinformation is as follows. The first premise is that a large proportion of science graduates disagree about human-caused global warming. And the second premise is that if a person has a degree in science, that makes them an expert in climate science. And the conclusion is that there's no scientific consensus on human-caused global warming. Now, step two in our methodology is this argument logically valid? And in other words, if both premises are true, assuming both premises are true, does it follow that the conclusion must also be true? And in this case, the answer is yes. If a large proportion of science graduates disagree about climate change, and being a science graduate makes you a climate expert, then yes, it would follow that there's no scientific consensus on climate change. And so having a logically valid argument, now we can go to step three, checking the premises. And this is where we see the misinformation goes wrong. We saw in van der Linden's experiment that there were multiple places where the misinformation was misleading. And going through this step helps us see exactly where and how the misinformation is misleading. The first premise is false because 31,000 is not a large proportion of the entire community of science graduates. It's actually only 0.3% of the community of US science graduates. And secondly, the second premise is false because just because someone has a degree in a field of science doesn't mean that they are necessarily an expert in climate science. Being a computer scientist doesn't make you an expert in climate science. And so this three-step process helps us see that the myth about the global warming petition project has multiple fallacies, which are magnified minority and fake experts. So let me give you a second example of deconstructing, because there was an extra step in our methodology, which I didn't cover in that first example. So this is an argument in a different topic, which was quite popular in March and April of 2020 in the early stages of the pandemic. We heard a lot of people arguing, well, not a lot, but some people arguing that because back in April, March and April of 2020, at that moment in time, fewer people, and this is mainly US based, like my work was mainly focused on misinformation in US media and from US politicians. At that time, less people had died in the US from COVID-19 than had died from the previous flu season. And so the argument was, well, we didn't close society because of the flu, so why should we close society because of COVID-19? Basically, the argument was that COVID was just as bad or not as bad as the flu, and less of a threat than the flu. So let's do the first step in our methodology and deconstruct this claim. And basically, and this was around April, I think, in 2020. The first premise in this argument was that in the previous flu season, over 30,000 people had died from the flu. And around that time in April, around 5,000 people had died from COVID-19. And so the argument was that COVID-19 was less of a threat than the flu. So that's step one. We've deconstructed the argument. Step two, is this argument logically valid? If the premises are both true, does it logically follow that the conclusion must also be true? And in this case, the argument is logically invalid. It doesn't follow. Just because COVID deaths were less than flu deaths at that moment in April, that doesn't necessarily mean that the situation would stay that way. And so you can't assume, you can't conclude that COVID-19 was less of a threat just because of having less deaths at that point in time. And so that means that there is an unstated assumption in this misinformation. And in order to make this argument logically valid, you need to add that third premise. And a third premise that makes this a valid argument is that the assumption that the number of COVID deaths in April would stay less than the number of deaths due to the flu. And well, firstly, by adding this, now we have a logically valid argument, and we can move to step three and check whether the premises are true or not. And by doing that, now in step three, we see where this misinformation goes wrong. It makes the assumption that just because COVID-19 deaths were less than the flu deaths in April, it would stay that way. And experts were saying that this was a false assumption for two reasons. It was ignoring the fact that COVID-19 was more infectious than the flu, and it was also ignoring the fact that COVID-19 had a higher mortality rate than the flu. Put those two things together, and the experts were predicting that we would experience significantly more mortalities from COVID-19 than from the flu, which is exactly what happened. The experts were right. And so this technique of ignoring relevant pieces of evidence before coming to a conclusion is known as slothful induction, not considering all the evidence, particularly relevant evidence that affects your conclusion. And so what this process does is it helps us see this is where the misinformation goes wrong. It ignores that COVID-19 is more viral and more deadly, and therefore comes to a false conclusion. And I've also been experimenting with how do you explain fallacies like slothful induction to people. And I found that analogies are a powerful way of explaining logical flaws in misinformation. And analogies, this technique is also called parallel argumentation. They're also a way of taking abstract logic and making it concrete. And thirdly, they can also be highly engaging and memorable and more viral, more likely for people to share them with other people. So the argument that COVID-19 is less than the flu now, so it's always going to stay that way, it's essentially the same as falling from a great height and saying, well, I haven't been hurt yet, so I'm not going to be hurt. It's ignoring bad things that are coming down the pipeline. And I will come back to this technique shortly. But I'll pause there again and see whether there are any questions that people might have.
Yeah, we have 2 questions from Stephen Harnett. The first one is related to the analogy of immunization against misinformation. He's asking, is it really immunization or more teaching self-medication or better consumption habits?
Self-medication. So, well, I mean, it's kind of potato in a way. Like, I guess it's immunization in the sense that you, the scientist, the communicator, the educator, are providing this to people. But, you know, in a way, people could self-immunize if they go and proactively go and find this content that teaches them the techniques of misinformation. Either way, the content, the inoculating content is out there, and we need to convey that to people, whether they get it for themselves or whether we find ways to communicate it to them. And so the dynamic here is, regardless of how they get it, the dynamic is when people are aware of the techniques used to mislead them, then they are more resilient and less likely to be misled. So I don't know if that satisfactorily answers the question, but hopefully it helps.
Thank you. And the second one is, would a course on rational inference have the same effect than this intervention?
Definitely yes. Really, what this research shows is that critical thinking is an important element to building public resilience against misinformation. And critical thinking is a very broad umbrella. Within it, you have media literacy, which is a lot of people are working on building people's media literacy so that they're able to more accurately assess the reliability of information sources. I guess rational thinking, assessing argument quality is another element of critical thinking. And so what I'm talking about, being able to identify rhetorical techniques and logical fallacies, is really a subset of all of that. And if you can go broader and deeper and make people more robust critical thinkers, then that just even further builds resilience against misinformation. My discipline is communication more than education, although I'm finding myself getting pulled more into the education sphere over time because of where my work is taking me. But being a communication scholar, my question has always been, what messages can we develop and then disseminate, whether it's through social media or print or mainstream media or classrooms or whatever, and explaining fallacies through communication is one way of doing it. But I think that educational resources that teach deeper critical thinking in the classrooms is even better and more ideal if it can be done.
Okay, thank you very much. We have one more. Nicola asks, this method of debunking is effectively quite similar to a regular critical thinking or intro to logics class. What are the specifically cognitive psychology elements and media literacy elements of the method you would deem most valuable? And how do you think they are best transmitted?
That's a question I have to think about for a moment. So what are the cognitive elements that are most important, I think?
The media literacy elements that are most important.
Yeah, so it's a good question. And I'm just going to start talking, and hopefully the answer will come to me as I talk, because see, I see a difference between this kind of logic-based critical thinking and media literacy. Media literacy is really about assessing the reliability of sources. And often it's about, is this a reliable source? What I've been talking about, this logic-based critical thinking, is more about assessing arguments or content. And those can be different things. Assessing whether a source is reliable can be different to assessing whether just content is valid, regardless of where it came from. And so I don't really know how to answer that question exactly, because I guess in terms of inoculation theory, there are a couple of things going on there. In inoculation theory, they find that there are two key elements to an inoculating message. The first is warning people of the threat that they may be misled. The second is providing those counter-arguments that explain how the misinformation is misleading. And the interesting thing about inoculation theory research is that the warning actually does a lot of the heavy lifting. And so there's two elements to inoculation theory. There's the kind of emotive element, that warning, and then there is the more rational or critical thinking element, which is the counter arguments, and both are important. And so just that warning, getting people cognitively on guard and looking out for that potential misinformation misleading them is a crucial part of it. So that means that there are different psychological elements going on. There's an emotional element and a more rational element. In terms of how to best transmit them, that's really the rest of my presentation will look at that. So maybe I'll continue with my presentation, and we'll and hopefully you'll have got satisfactory answers by the end of it.
Thank you. We still have 35 minutes, so you can distribute it as you want.
Okay. All right. So continuing on then. So inoculation theory has been the foundation that most of my research has been focused on. And within inoculation theory, there are really several different ways to inoculate people against misinformation. And the two main ones are fact-based and logic-based. And I don't touch on this in my slides, but I will just quickly mention the third type being source-based inoculation. And source-based inoculation really is that kind of media literacy that I was just talking about, where you help people assess sources and whether they're reliable sources of information or not. But I want to focus on fact-based and logic-based because these are what my research has focused on. Fact-based inoculations show how the misinformation is wrong by explaining the facts to people, whereas logic-based inoculations show how the misinformation is wrong by explaining the rhetorical techniques or the logical fallacies in the misinformation. And so there are two different approaches. Often there's a bit of overlap because we found in our research that it's hard to explain the logical fallacy in misinformation without often having to explain some of the facts anyway. But some interesting research published a couple of years ago by Philip Schmid and Cornelia Betsch looked at these two approaches, fact-based and logic-based. They called them topic-based and technique-based. So I hope it's not confusing using the different terminology. But using the topics of climate change and vaccination, they tested these ways of debunking misinformation. Quick qualifier, they weren't doing inoculation or corrections before the misinformation. Their debunking happened after people were shown the misinformation. A subtle but important difference. So they found that when they debunked misinformation, either using the logic-based or the fact-based approach, and they actually used the same 5 techniques from Flick that I mentioned earlier: the fake experts, logical fallacies, impossible expectations, cherry picking or selectivity, and conspiracy theories. And they also looked at different topics within vaccination. And so they would show people some misinformation, and then they would show the debunking in response to it. And they found that whether they used the topic or fact-based approach or the logic-based approach, both were equally effective in countering the misinformation. But they also went on to say that because the same rhetorical techniques are found across different topics, explaining or using logic-based corrections can be especially powerful because it can convey immunity across different topics. And if you recall, this was what I found in my own research when I debunked or inoculated people against tobacco misinformation, and found that it conveyed immunity against climate misinformation. And so this is one of the, I think, the most powerful and attractive elements of logic-based corrections is the fact that they can convey immunity across topics. You can basically get more immunity for your buck with a single intervention, whereas with a fact-based correction, it only works in the specific context of those facts and that topic. And so in my own research, I've been working with my colleagues Sojung Kim and Emily Braga at the University of Minnesota and at George Mason University. And we've been testing different ways of trying to correct misinformation in different contexts, such as on social media. So yeah, we were concerned with the question that was asked earlier: how do you transmit this? How do you get this out to people? And so we tested in different contexts, like on Twitter and on Instagram. In one study, we basically tested 2 different forms of logic-based corrections. One of them was using the logical deconstruction method, which I just described to you, that critical thinking approach. And so we took some misinformation about vaccines and we debunked it in Twitter form. And our debunking included a graphic which showed the argument structure of the misinformation and also where it went logically wrong. Basically, the argument commits the fallacy of mistaking correlation for causation. Now, another approach we did, and I've hinted at this with a cartoon that I showed earlier, was using cartoon analogies to illustrate the logical flaws in the misinformation. And so basically what we did was we took the original logic of the misinformation in the first panel of this cartoon. So here's someone arguing something bad happened after vaccination, so the vaccination must have caused it. And then we transplant that logic into a parallel situation, which is obviously ridiculous. What a sports fan wears at the game affects the result. So therefore, if they always wear the same clothes, their team will always win. And so we're trying to use this example as a clear example of false misinformation that anyone should immediately recognize. Although my wife did point out that actually people really believe this. That's why sports fans all wear the same thing. But I'm going to give people more credit and hope that that they were able to obviously see the flaw in that argument. Now, what we did with this experiment, well, firstly, the key line result was that both techniques, both the critical thinking deconstruction method and the cartoon parallel argument method, both were equally effective in countering the misinformation and reducing vaccine misperceptions and reducing the perceived credibility of the misinformation tweet. But what we also did was, while participants were looking at these tweets, we were using eye tracking to measure what were they looking at for how long. And then we used mediation analysis to analyze what was the mechanism through which these different corrections were effective. And so what this mediation flowchart shows is the end result is reducing vaccine misperceptions. But what is the pathway through which our experimental conditions, whether it's the cartoon or the critical thinking graphic, what is the pathway through which it was successful in reducing misperceptions? And what we found was, I'm just going to move my little Zoom box out of the way so I can see. For the infographic, the critical thinking infographic, we found that through mediation analysis, it was perceived as being more credible compared to the cartoon intervention. And that higher credibility was what mediated the reduction in misperceptions, which is another way of saying the mechanism through which the infographic was effective in debunking was because of its higher credibility. Now, in contrast, the cartoon condition, that through our eye tracking data, we found that the people looked at the correction and the cartoon for a much longer time compared to the infographic condition. And it was that greater attention which mediated its effectiveness. In other words, both conditions worked, but they worked through different pathways. The serious condition was more credible, but the humorous condition attracted more attention. And it was through either this higher credibility or through the greater attention that the corrections were able to effectively debunk the misinformation. So what this tells us is that there is no single way to counter misinformation. There are multiple pathways, and these different pathways work for different ways. We then did some follow-up study further exploring fact-based and logic-based corrections. And so here was a study that we published where we were actually looking at debunking misinformation on Instagram. And the misinformation that we were looking at was the claim that CO2 is plant food. Plants need CO2 to grow. Therefore, CO2 is a good thing and we should be emitting as much of it as we can to help plants grow better. And so what we did in our experiment was we showed people this misinformation about CO2 being plant food, but then we also showed them corrections to debunk this myth. And we had two types of corrections, either a fact-based correction that explained the facts about how plants grow and how they need not just CO2, but certain conditions to flourish, but also logic-based corrections, which explain the fallacy of oversimplification, which the myth committed. And we used a parallel argument or an analogy. The plant food argument is exactly the same as arguing that ice cream has calcium and we need calcium. Therefore, all you need to do is feed people ice cream and that's all the food that they need. Obviously a ridiculous argument, but it's the same argument as the CO2 is plant food argument. Now, the other thing we did in this experiment was we played around with ordering. Either people saw the correction before the myth, in other words, pre-bunking, or they saw the correction after the myth, or debunking. And so there were basically 4 conditions. Either they saw the fact-based as a correction as a pre-bunking, or they saw the fact-based as a debunking, or logic-based as a pre-bunking, or logic-based as a debunking. And here are the results from our research. And I will point out that what we were measuring here was misperceptions, like agreeing with the myth of CO2 being plant food and therefore a good thing. So that means that the higher up the value, the worse it is. We don't want people believing this misperception. And so when people were shown just the misinformation by itself, it had a positive, that was the strongest levels of belief in the misperception or belief in the myth. But what our research found, and I'll just direct you to the 2 rightmost bars here. These are the logic-based correction, either happening before or after the myth. Basically, we found that the logic-based correction works regardless of order. Whether people have the logical fallacy in a myth explained to them, it doesn't matter whether the logic-based correction is encountered before the misinformation or after the misinformation. Now, in contrast, if you look at the fact-based conditions, it does matter. If the fact-based explanation comes last, if the facts are the last thing that people see, that's more effective. But if the myth is the last thing that people see, so they see the fact-based correction first, and then the myth comes afterwards, then the myth can cancel out the facts. And this kind of mirrors that cancelling out effect I mentioned from Van der Linden's study. Myths can cancel out facts. And so that means that when we send our facts out into the world, they are vulnerable. They can be cancelled out by misinformation. Logic-based corrections are more robust, and ideally, I think, wrapping some critical thinking around our facts it's like wrapping bubble wrap around our facts and our explanations as we send them out into a dangerous world. And so we just need to be aware of these potential vulnerabilities when we're engaging with the public, communicating facts and explanations to them, being aware of that danger that misinformation can cancel out the positive effects from our communication, and trying to mitigate that by also explaining to people how misinformation might try to distort the facts that we're explaining. So moving on, I wanted to talk lastly about one other way of inoculating people against misinformation. Everything that I've talked to up to this point has been what we call passive inoculation, where I'm communicating my inoculating messages in a one-way direction, and the audience is passively receiving those explanations. But there is also another form of inoculation called active inoculation. But I just realized I probably should use this as a pause point in case there are any further questions. So, are there?
I'm not sure. Just reminding, no new question, as you can see. Okay, just reminding the people in the public they can send their questions. Otherwise, we still have maybe 10 minutes to have 5 of discussion, or 5 minutes and have 10 of discussion, whatever you prefer.
Great. Okay. All right. I'll press on, and then we can, if there's any questions at the end, we can continue. So, all right. So active inoculation involves inoculating people in a much more interactive way, and specifically, it's about teaching people the misleading techniques in misinformation by having them do the misleading techniques and misinformation. It's kind of like teaching people how to cheat at cards so that they can spot other people cheating at cards. And the pioneer in this work is Sander van der Linden in a digital game context. He's basically, a few years ago, he developed a digital game, Bad News, which inoculated people against 6 techniques of fake news. And the way that the game was structured was your goal in the game is to become a fake news merchant, basically, and try to accumulate as many Twitter followers as possible. And so you learn these different techniques and apply them. But what Sander found was by the end of the game, by becoming a fake news merchant within this game, people also became inoculated against those 6 techniques and were able to spot them in social media. And the power of active inoculation and using games to interactively inoculate people is it answers a lot of the questions and challenges of inoculation that I'd been struggling with and had no answer to up till this point. Basically, I saw that there were 3 significant challenges to inoculating the public in a way that's scalable, that can reach a large proportion of the public, and in a way that is effective enough that people are effectively inoculated and more resilient. And these 3 challenges are this. Firstly, psychological. You recall that taxonomy of denial techniques I showed, a full screen of different techniques. That is a lot to teach people. And it is also, you're trying to teach people how to become better critical thinkers. Critical thinking is hard. Our brains are hardwired for fast, easy thinking. Heuristics, mental shortcuts. It's not because people are stupid, that's just how our brains are hardwired. The human brain evolved to deal with immediate, quick problems. And so while we are able to reason through difficult problems like assessing argument structure, it's not something that comes easily, and therefore we don't do it that much. So this is a very basic, fundamental psychological challenge to inoculating people against misinformation. The second is structural. The way the media landscape is now, people can pick and choose where they get their information from, whether it's cable TV or social media or the algorithms that social media platforms use to deliver information that we already agree with. And so that media landscape is very challenging because communities are all siloed. It's hard to get inoculating messages to the communities that are most vulnerable to being misled by misinformation. The third challenge is social. Issues like climate change and other polarized issues have become very tribal. We not only believe things because of the facts or the evidence or the information that we have at hand, we also believe things because that's what our tribe, our social group believes. And for us to change our minds means to disagree with our social group, and that can come at a social cost. So that places strong disincentives on people changing their minds if their social group believes a certain thing. So these 3 challenges, psychological, structural, and social, make it very difficult to inoculate the public at scale, which is what we need to do to effectively build public resilience against misinformation. And games offer the potential to resolve all 3 of those issues. What I've been working on for the last couple of years has been a game that, similar to van der Linden's Bad News game, uses active inoculation to build resilience against misinformation. So the game is called Cranky Uncle, and the goal of the game is to become a science-denying cranky uncle. As you go through the game, you earn cranky points and your mood gets crankier and crankier. Your cranky uncle's face gets redder and redder as you get further into the game. You know you're doing well if steam starts coming out of his ears. You're getting to some of the higher levels then. And the way the game works is it explains to you, Cranky Uncle mentors you through learning the different techniques of science denial. We see on the right screen here the 5 techniques of Flick, fake experts, logical fallacies, etc. And through this game, Cranky Uncle basically explains to you how to deny science using lots of analogies and cartoon parallel arguments. But then, importantly, the game gets you practicing critical thinking. It shows you examples of misinformation, and you have to identify what is the fallacy or rhetorical technique in that example of misinformation. And by doing that process of spotting misinformation over and over and over again, the game gets you practicing critical thinking to the point where that difficult, slow thinking, critical thinking process becomes faster and easier, and it essentially becomes like an instinctive, instant reaction. That's the power of games. It can use gameplay elements like leveling up and accumulating points to motivate people to keep playing and therefore keep practicing critical thinking until they become experts. The second challenge is structural. How do you reach all these siloed communities? Because I have very limited capacity to get my inoculating messages to people on social media. But what I've learned through developing this game is educators are crying out for these kinds of interactive, engaging resources. And so that motivated me to develop a teacher's guide to make it easier for teachers to use the game to teach critical thinking in their classrooms. And so we included a lot of different classroom activities in the teacher's guide and found that very quickly teachers were signing up for the game all throughout the US as well as in other countries. Initially, I was focused on the US because I was based there through 2020 when the game came out. But we're now working on translations and we'll be translating the game into about a dozen languages over the next few months. What's really surprised me about teacher adoption of the game has been just how broad the adoption has been, not just geographically, but across different subjects. Because there's an emphasis on environmental science and climate change in the game, I was expecting just those subjects to mainly focus on it. But to my surprise and delight, I've found that teachers across a whole range of subjects have been interested in teaching critical thinking to their students. And that really underscores that critical thinking is a skill that are needed across all topics, not just climate science. And lastly, I originally, and perhaps this is due to a lack of imagination, but I conceptualized the game as being for college students, but found that, to my surprise, it was being adopted at the high school level and even middle school and a couple of elementary schools. So we're still collecting the data from within the gameplay to assess how well the game works at those different levels. But again, I think that teaching critical thinking and building student resilience against misinformation at the middle and high school level is really important as well. And so that I think in the classroom is how to resolve that structural challenge of reaching people who I otherwise would never be able to reach. And thirdly, the social element. The problem with polarized topics is because it's tribal. That tribality means that people even respond to your messages. They can be resistant to it if it's perceived to threaten their social identity. But what games can do is appeal to people's tribal instincts to motivate them to do positive things. And so what we've been playing around with now is using contests, getting people competing against each other and competing in groups. And what that then does is it taps into their tribal instincts, but to motivate them to build their resilience against misinformation, whereas tribalness usually motivates them to reject information that threatens their social identity, or it also can motivate them to be more vulnerable to polarizing misinformation. So these are three ways that gamification can overcome some of the cultural, social, and structural challenges of misinformation, and also at scale. And I think at scale is a really important consideration, given the immensity of the problem of misinformation and how it afflicts society. Lastly, here are the three ways that people can play the game on iPhone, Android, or just simply in their browsers. And so, yeah, I recommend you check it out, and feel free to reach out to me if you have any questions about the game or about any of my research. And at this point, I might stop sharing, and I'll be happy to answer any further questions in the time we have left.
Dr. Cook.